Next, we are going to see how to find manuals and how to read them.
So you can go to C drive. Okay. So when you're installing the software now, it will ask you the location of installation. Okay. So you define the C drive. Okay. It will be safe for installation. Okay. So like I define the folder, by default, it'll make a folder of LS Dyna. Open that folder and you'll find here manuals. Okay. So here manuals and some theory and other things will be available. Okay. So whenever we require some help or something, we need to read more about that particular thing. Okay, we refer manuals only. Okay, so like here, like if you want to study what is that ALE stand for. Okay, so ALE does not support implicit time generation or not support a dynamic relaxation. So like this, you can have a ALE. Now in ALE, what kind of keywords is available? These all keywords are available in ALE. Okay, if you're taking particular ALE, let me show you. Like this, we have taken ALE ambient hydrostatic. Okay, so in ambient hydrostatic, when I define that value in ALE, what kind of things I have to require? So I'll show you here. So where we required ALE SID, define the reservoir type. This is for example I'm telling. So this is required. Okay, where ALE domain mesh hydrostatic pressure field due to gravity, it'll give you the detail from here. Like this, you'll get the details. Okay, S type, again set type. So we'll get part like when we defining anything, that will be a simple part we are having, or if we having multiple bodies are there, or we are making into one part set ID, like two bodies are there, and I converting the two body into one part set. Okay, group of, you can say simple group. So if I contain part set ID, so I will define part set ID. The same way, if I have solid set I'm creating, so solid bodies are there and solid set I'm creating. So I define a solid set ID. Okay. So vector ID, any directions that is required to define in this ALE, gravity, P, you can read it out. What that exactly? Nominal reference pressure. Okay. Okay. RM stand for ramping time, function load curve ID. Okay, NID stand for node ID. So this thing is required. If I'm going with ALE, I have to define this thing. Okay, I have to define this thing. The same way, suppose if you're taking any boundary condition you want to apply. Suppose you say, sir, I want to apply particular boundary condition. Okay.
Exactly, what is the meaning of ALE?
ALE basically used for we can say water and fluid type of kind of problems when we are solving with the explosion and all. Then it is required. Okay. In simple language, if you go with the ALE definition.
What type of analysis are they doing in ALE?
Basically, explosion or water fluid kind of cases when we are doing it, then we are using multi-material cases when we are doing multi-material cases when we having, then we are using ALE. So you can see here. So ALE support only one point solid element. The solid elements can be hydra that all. But for example, for each we'll use ALE multi-material and stress and strain, evaluate solid elements, single integration point. So in that kind of forms we can use ALE. So it's different problems like hydrostatic. Okay, we are using you can say here some water cases we can use it, water and air cases when we are using, then we can use it. Okay, some explosion cases we are doing, and then we can use it. Okay, so every thing will be there. There will be different things will be there when we're using gas and other like air, water, or we can say any other fluids. When we are using, then also we can use it ALE. So we have to like ALE means what happened. Like if I say this is the water. Okay, this is the water. This is my plate here. Okay, like a detonation here, blast we having here. So in this, like maybe air will be also, if air case will be there, we'll put air case also there. Okay, so this will be happening. I want to see in the fluid, okay, the deformation on the plate. Basically, ALE cases are like we directly do not see any deformation on the parts. We do not see the deformation directly on the parts. In this case, kind of cases when we performing a simulation, to see that effect of that deformation, but that exactly impact happening on a blast or something. So impact on part. If you want to see the impact area, the ALE will be help us to show that particular thing. I hope I'm clear to what I'm saying. It's clear. If I'm not using ALE, then I cannot see the impact at that particular position in the case of water and that kind of cases.
That is ALE means that is card or that is.
It's all like a card things we are specifying. We have to specify. We have to make a ALE for water. We have to make a ALE for blast, ALE for air. We have to see the deformation effect on the particular situation. If you're not defined,
ALE means there is a particular analysis, right? Or that is not a
particular kind of analysis we can say. In that situation only we can use ALE. Otherwise, ALE is not required. In normal analysis, ALE is not required. Only that kind of situation where air, water, and multiple materials are coming, and that kind of materials are coming. Only that cases ALE is required. Otherwise, ALE is not required. Okay. We are using like you can see that material kind of like single gaseous material, like we are using ideal gas or linear polynomial. Null is stand for water, air, or any fluid we can take for that. Null cases we're using that kind of material or gases. So there we use ALE and other things. Like their equation of states when we're doing again blast kind of problems when we're doing, we have to define equation of states. Okay, EOS basically, and EOS again different things will be there that need to be defined. For velocities and all, we're using basically when we're defining velocities to the parts, we're using initials. Okay, so how the velocity is defined? So there will different ways are there, different things. Normal if you define normal velocity, we can use velocity option. Okay, if we are generating a velocity like explosion cases and all, we use velocity generation. Okay, so that different cases are available. Okay, now like if you want to read about materials, okay, this is volume 1 where we having a maximum journal introduction about all the keywords. Okay, this is about keywords basically. Then you can go to volume 2. Volume 2 will be on equation of states. You will get more information about equation of states in volume 2. Okay, you can read it about that particular EOS. Then for material, we will follow this one here. Like if I'm using any particular material, okay. For example, we'll take some material. Okay, like here we have. Let me take a simple one. Mat 5. Mat 6. Mat 8. Okay. Okay, this every in like we having a material number will be available. Mat 9, Mat 6, Mat 5. So the number will be basically telling that particular material, Mat 1, Mat elastic material, not material. So it is numbered actually. Okay, so as I told you, like null material. So in which cases you can use this type of material. So in this case, solid and thick shells. This material allow you equation of states. Okay, if I using null material, okay, then I have to define the equation of states to be considered without computing Devittry stresses. Okay, if I'm not defining EOS in this, I cannot get the results that I want. So every material will be required something. Okay, so that we have to give that values. We have to, like you can see here. Like we know material ID, we know RO is stand for density, like Poisson ratio and other things. So again, this terms something I also don't know, because when I go to the software only, I can only tell that what exactly that this particular things will be stand for. Okay. Or if you want to know before that, you just open that material, like I open this null material. So in this null material, MI stand for material identification, RO stand for mass density. Okay. And G stand for shear modulus. SIG stand for yield stress. ES stand for plastic hardening. So this is how I can get the details. So if you have complete data, you can put the complete data and you can find the results. But sometime, like same like in Ansys also, example, if you're doing Ansys, we always give only those properties where we have to test it. We unnecessary, we do not define all the properties. Property software will ask you, it will ask you so many things, but we have to test it. Which properties we have to test it? Only we have to give only those property there. Okay. So according to requirements of my solutions, which properties I want to test this in the model, that property you have to fulfill. Okay. Because some property I can't say the data is available. Maybe I don't have all the data. Maybe even Google we are searching, we're not getting data because there's some standard data, standard books we are following. Only the data can be collected from that party standard books. Okay. So we have to follow the standard materials list that is available in industry. Mostly, I think that kind of material data will be available that you guys can take and use it. Okay, and this manual is not required for us much. Third one, volume 1 and volume 2 will be helpful. Okay, this is about the introduction, CSC and all. Okay, that we don't require. Volume 2 and volume 1 you can refer it.